Hey there, and welcome. Today, we're going to pull back the curtain on the internet to look at the actual blueprint that makes our entire digital world tick. Let's get right into it.
So, have you ever really stopped to think about it? You click on a link, and almost instantly, a web page just appears. But here's the thing. It isn't magic. It's this incredible, super high-speed journey, and today, we're going to follow the data and see exactly what happens from the very beginning.
Believe it or not, this global network we use for literally everything, from binge-watching shows to calling our parents, actually started as a project for the U.S. Department of Defense. They had a really specific problem. They needed a communication system that could survive an attack, a network that could keep working even if parts of it got knocked out. And that one single idea, resilience, became the blueprint for everything that followed.
So how did we get from that military plan to this? It happened in a few key stages. It all kicked off in 1969 with ARPANET, which connected a handful of universities. Fast forward to the mid-80s, and the National Science Foundation built something called NSFNet, which was like a super-fast highway or backbone for the network. And then, over time, these networks and tons of other smaller ones all started linking up, creating this massive, sprawling network of networks that we now just call the internet.
Because when you boil it all down, that's what the internet is. Just one gigantic computer network. And a network, at its most basic level, is just a bunch of computers and devices, your phone, your laptop, whatever, all connected so they can talk to each other and share stuff.
But, just plugging a bunch of computers together isn't enough. For them to actually understand each other, they need a shared language. They need a set of rules. It's kind of like establishing the rules of the road before you let all the cars on the highway. And for any of this digital chatter to happen, you absolutely need these 5 key players. You've got the sender, that's the device sending the info, the receiver, who's getting it, the message itself, the medium, which is the physical path it travels on, think Wi-Fi signals or fiber optic cables, and most importantly, the protocols. Those are the rules we just talked about.
Honestly, protocols are the unsung heroes of the internet. They're the strict rulebook that every device agrees to follow. You can think of them like the grammar of a language. Without them, you just have a bunch of computers shouting digital gibberish at each other. They'd be connected, but they wouldn't have a clue what the other was saying.
Okay, let's talk speed. This is where 2 words get thrown around a lot and often get mixed up: bandwidth and data transfer rate. And this analogy, it's perfect for explaining the difference. Think of bandwidth as the number of lanes on a highway. It's the potential amount of traffic it can handle. But the data transfer rate, that's the actual speed limit of the cars on that highway. So having a 10-lane highway doesn't guarantee you can go 100 miles per hour, right? Same idea here.
All right, so we've got the roads and the rules of the road. But in a sea of billions of devices, how does your email find its way to your computer and not your neighbor's? Well, just like the Postal Service, it needs an address, a digital street address.
And that address is called an IP address. IP stands for Internet Protocol. Every single device that connects to a network gets one of these unique numerical labels, and it does 2 really important things. It identifies what the device is, and it tells everyone else where it's located on the network.
But here's a cool fact. Your device actually has 2 addresses. The IP address we just talked about is temporary. It's like your hotel room number. You only have it while you're connected to that specific network. But your device also has a MAC address. Think of that like your passport number. It's a permanent, physical address that's burned into the hardware from the factory, and it never, ever changes.
All right, this is where it gets really, really cool. We've got the rules, we've got the addresses, but how does the message actually make the trip? This is the secret sauce, the ingenious engine that makes the whole modern internet go.
So back in the day, the approach was something called circuit switching. The best analogy is an old-school landline phone call. Before you could even say hello, the system had to physically create a dedicated, private line just for you, all the way from your phone to the person you were calling. That line stayed open, completely reserved for you for the entire call.
But the internet does something way smarter. It uses packet switching. Instead of one big dedicated pipe, it takes your message, an email, a photo, a video stream, and chops it up into thousands of these little digital envelopes called packets. Each packet gets the destination address stamped on it, and then it's sent out into the network to find its own way there, just like letters in the mail. And when you put them side by side, you really see the genius of it. With circuit switching, that dedicated path stays open whether you're talking or not, which is super inefficient.
It's like renting an entire highway lane just for yourself, even when you're parked. Packet switching lets everyone share the road using only the resources they need when they need them. It's more efficient, it's way more robust, and honestly, it's the only reason the internet can work at the incredible scale it does today.
So what does this actually mean for you? Well, here's the crucial takeaway. Packet switching is the reason your video call doesn't just die if there's a traffic jam on some network cable in another country. If one path gets blocked, the packets are smart enough to just take a different route. They find another way to get to their destination. That's the resiliency that was built in from the very beginning.
So the entire digital world we live in was built on this one brilliant idea of breaking things down into little pieces and letting them find their own way. It really makes you wonder, right? What's the next revolutionary idea out there that's going to completely transform how we all connect?